Could there be intelligent life beyond our solar system? If so, how will we find it? What will it look like? And how seriously should we take UFO sightings? In this episode, astrophysicist Adam Frank talks all things extraterrestrial.
Hi, I'm Adam Frank. I'm a professor of astrophysics at the University of Rochester in New York. For many years, I was a computational astrophysicist, studying things like how stars form and how they die. But over the last 10, 15 years or so, I've turned to astrobiology, asking a question that I asked when I was a kid, which is, is there life out there? Are we the only time in the entire history of the universe that life of any form has come to pass?
Great. I mean, it's fantastic to have you on the podcast, Adam. Thanks for coming on.
My pleasure.
The reason we're talking today is because around about the time this podcast comes out is your latest book will be out, which is called The Little Book of Aliens.
Yep.
Which I suppose is sort of a scientific look at humanity's fascination with that question. Are we alone? Is there life beyond Earth? But would you say it's more a scientific approach to the question rather than maybe what the general population might be used to in terms of UFO and lore like that in popular culture?
Yeah. I wrote the book because, it's interesting. This is a really interesting moment in human history. And I wrote the book to give people a view of what's about to happen. Because what's interesting is, on the one hand, on the scientific side, we have never, when you look at the course of human history, people have been arguing about whether or not we are the only intelligent species, or whether the Earth is the only place that life has happened for literally 2,500 years. In the book, I talk about how, you can see the Greeks arguing over this question. And now, remarkably, scientifically, we are poised to answer that question with things like the James Webb Space Telescope and the new telescopes we're going to be putting in orbit over the next 10, 20, or 30 years. We're really in a position to answer that question where we weren't 10, 15, 20 years ago. So we're at this remarkable moment where we're like, we're at the shoreline. We're about to put the boats in the water and start, what is literally the most remarkable journey human beings have ever taken. And at the same time, we've got all this UFO stuff happening. Suddenly, UFOs are in the news in a way they haven't been before. And I wrote the book to let people understand, try and show people the history of the field, where we are scientifically, and really, some stuff. I talk about UFOs, the history of UFOs, and, sort of what's wheat and what's chaff in UFOs, what part you should be skeptical of, and what part, maybe there's worthwhile looking at scientifically.
I mean, do you think that we are close to finding signs of intelligent life, or would a scientist even ask that question?
No, scientists, we are. So I am. One of the reasons I also wrote the book is I am the principal investigator on NASA's first grant to look for signs of intelligent life. We are absolutely at the point with our telescopes, we will have the capacity. We have the capacity now, as a paper that my group has written, to find signatures, what we call techno signatures, of alien civilizations on alien planets. We are poised to be able to do that now, just like we have the capacity to look for signatures of just, what I call dumb life. I don't mean to insult microbes, but of, microbial or plant rich biospheres, alien biospheres on alien worlds. We can do that now. That's what I'm trying to let people understand, that we are just at the edge of being able to have this capacity. And in the next 10, 20, or 30 years, we'll have data that is relevant to this question, as opposed to the last 2,500 years of people yelling at each other about their opinions, man.
Those two terms, biosignatures and technosignatures, essentially looking for signs, not actually being able to directly observe life, but looking for signs of life. How do we do that? And I suppose what are the upcoming missions, or even current missions, that you're sort of most excited about?
Right. So when people think about the search for life in the universe, because of the history of it, we tend to think of SETI, right? We tend to think of, people with giant radio dishes, listening for signals from alien civilizations, like actually like somebody's beamed us a signal that's going to have the cure for cancer or something in it. And that is where, in some sense, where the SETI began in 1960. But the search for life now, and the search for intelligent life now, has moved way beyond that. I mean, that's still a viable way of looking, but what has happened is, in the 1990s, we discovered our first exoplanets, right? We discovered the first planets orbiting other stars. And that was also a question you can see the ancient Greeks beating each other up about. So in the 1990s, 1995, we discovered the first planet orbiting a sun-like star. And that was a revolution. That was the beginning of the profound change. Because when people were thinking about looking for life among the stars beforehand, they had no idea where to look, right? Which star do you look at? How long do you look at it? And then starting in the 1995, we started discovering what we call exoplanets. And since then, we have had a revolution, a profound expansion in human knowledge, such that now when you go out and look at the sky, every star, pretty much every star you look at has a family of worlds. We know that for a fact. Every star has a family of planets orbiting it. And if you count up 5 of those stars, one of them has a planet in the right place for life to form. And what I mean by that, that's what we call the habitable zone. That means that 1 in 5 stars has a planet in the habitable zone. And the habitable zone is the place where if you poured water out on the surface, right? If you had a jug of water, and of course you have to have an atmosphere, but assuming you have an atmosphere, and you poured water out on the surface, that you could get, the water would sit there in a pool, right? A little puddle. You could have liquid water on the surface. That's the basis of the habitable zone. So what we've come to recognize is that the universe is awash in planets. So that was the first thing. Many of those planets are habitable. Doesn't mean they're inhabited, but they are habitable. And then what happened? So that's revolution number 1. Revolution number 2 was we started detecting atmospheres on these planets, and we learned how to look at the atmospheres of these planets. And by looking at the atmospheres of these alien worlds, we're getting more and more sophisticated at sniffing out the chemical composition of these atmospheres, or detecting other things that are happening on the surface of the planets. And so that leads to this idea of signatures, either biosignatures or technosignatures. Because what we can do is we can now look at these worlds. We can see these worlds directly through their imprint on the starlight. And we can look at the light that is either reflecting off the planet or passing through the planet's atmospheres, and see the imprint of things like oxygen or ozone. So ozone is a chemical. Ozone is 3 oxygen atoms together. It would, as far as we know, other than very special circumstances, it's only going to be there if life puts it there, right? The only reason there's oxygen in our atmosphere is because 2 billion years ago, life put it there. So oxygen is a biosignature. You find oxygen in an atmosphere, you have a good shot that you just discovered an alien biosphere, right? Likewise, things like there are chemicals that would be in an atmosphere that would never occur naturally. Things like chlorofluorocarbons, for example. If you detect chlorofluorocarbons in an atmosphere, which we can do now, you would have found evidence that there's a technological civilization on that planet. So, I mean, this is amazing. This is what I'm trying to tell people in the book. That's one part of the book, and explain to them how this is going to happen. We now, for the first time in the history of human race, have the capacity to look at alien planets and detect alien life.
Amazing. But how easy do you think it is to get from we've found evidence of alien life to we've found alien life?
Well, that's science, right? That's, what you got when you first think you detect something, everybody freaks out, and we have, we're all, it's a party. And then the next thing you do is like, wait, did we really find alien life? And so then you're going to have to start looking at the context, right? You'll study. Imagine if we found a world with, we thought we found oxygen, right? We found a biosignature. Well, what do you think the next step is? We're going to train every telescope we have at that world. We're going to monitor it continuously. We'll send giant spaceships into giant telescopes into orbit to study it even more. And over time, we'll accumulate more and more evidence to confirm, or, either confirm that conclusion or show us that, no, we were mistaken. So, what's amazing also is that the astronomical community has become very sophisticated in our understanding of what a biosignature was. So back in the early 2000s, right, people were like, oxygen, if you find oxygen, you're done. And now we've realized a couple ways that oxygen might be produced naturally. So we've got that in our pockets. And also we're starting to develop a whole set of other methods that are very much agnostic about what kind of life it is, that are agnostic to, you don't want to just use Earth life as your example. So people have been developing ever more sophisticated, structured, mathematically structured, sophisticated, complex ways of telling whether or not we're fooling ourselves, right? Because that's this is when we get to UFOs, this is gonna be a thing. Human beings, it's very easy for us to fool ourselves, especially about something we want to be true. And the whole point of science is to be sure that I don't want to believe, I want to know. So imagine that we found oxygen and we're monitoring this planet. Now what we'd look at is we're like seasonal, right? We know that the Earth has biosignatures. The Earth has had biosignatures for billions of years. They vary over time, right? As the Earth, summer to winter. You can see variations in the Earth's spectral output, how the light changes because of all the forests. So we'd look at this other planet, we'd monitor it over years. And every piece of evidence would either help us confirm, like, yes, this is totally a biosphere, or maybe it would start to chip away at the idea. And that's what makes science so powerful and wonderful.
Absolutely. But you sort of touched on something I've always wondered myself, and that's if astronomers cosmologists, astrophysicists from another civilization beyond Earth were trying to find life somewhere else, what would Earth look like to them in terms of their data, like the data they collected? If they recorded a spectra of the sun's starlight passing through Earth's atmosphere, what would they see, and how would they then follow up their investigations?
Earth, that's a great question. And there are a lot of people a lot of people have used Earth as a test case for bio and technosignature studies. So people have used Carl Sagan was the first to do this. When the Galileo space probe was on its way to Jupiter, it had this complex orbit where it was using gravitational assists to fling it out to Jupiter. And it went by Earth one time. And Sagan, being Sagan, convinced the people at JPL, the Jet Propulsion Laboratory, to turn the camera to Earth and take a bunch of images and take a bunch of spectra. And that was the first time you could see that there was this wide variety of spectral features that completely told you Earth was inhabited by life, and that Earth also had a technological civilization. So, for example, there's something called the red edge. If you look at the reflected spectrum of light from the Earth, the light bouncing off Earth, what you see is that the reflectivity of the light jumps really rapidly right at the edge between at red light, right at where the red wavelengths are. And that is because of all the chlorophyll. It's basically all the leaves, in some sense. So all of those photosynthetic stuff on the surface of the Earth changes Earth's spectrum. So there's this very sharp spectral edge. And there were other things as well. So the Earth has been showing its biosignatures literally for billions of years. And recently it started to show technosignatures. So any alien species that's been out there monitoring the galaxy, looking around, Earth would have shown up as an inhabited world for quite a long time. And think of it, we're just starting this game, right? So, we're just now turning our telescopes with the technological capacities to find life. So this is a pretty exciting moment. We're about to join that galactic club, if it exists, of species that are going out and saying, oh, that world looks like it. That world has life. That world doesn't. That world might have life. That world totally has life. So it's a pretty interesting idea.
Absolutely. It sort of brings us on quite nicely because you've mentioned it already, and I think it's definitely worth mentioning. I really wanted to gauge your opinion on UFOs, UAPs. How do you react to the legacy since sort of the mid 1940s of popular UFO lore and Roswell and all that sort of, like, where does that fit in with your sort of scientific analysis of the entire question?
Yeah, so let's talk. I go into this book. I know people are interested, so I did my best to look at, I read, a bunch of stuff on Roswell and everything. And here's my take on it. There is absolutely, at this point, no evidence that any scientist who, would waste their time, right? Because that's what we do as scientists. We literally take our time and we waste our time, studying things. And it takes a long time. It takes a lot of effort. If you're going to do a scientific study of something, you're really betting your life, years of your life on something. And there is no evidence to date that is associated with UFOs or UAPs that warrants the conclusion that anything we've seen is extraterrestrial or is beyond human capacities, right? I mean, that's just, I don't see any way around that. That doesn't mean that what's happening now isn't worth study and we shouldn't put some time into study. And I'm for, what NASA is doing, like the NASA panel. I think that's good. But there's just simply nothing out there from the scientific perspective that makes you say, oh my God, for sure, these things that are being seen are somehow, are exhibiting technologies or behaviors that are beyond anything we understand on Earth. And so let's just break that down a little bit, and then let's go into the history, right? So, because of the media fascination, and because of the lore, as you say, people have this idea like that every day people are seeing things in the sky that they, can't be explained. NASA convened a panel in the wake of what happened in 2017 with the release of those Navy pilot videos. So NASA convened a panel that looked at I think there was the military had put out a report that it had data with like 120 or so, around 100 sightings that it couldn't explain. And so NASA sorted through that data, and they said, and what they found was they could explain 94% of them. 94% of them had explanations. 6% didn't. And some of those that couldn't is because he didn't even have enough data to begin trying to make an explanation. And pretty much when you look at the history of people doing studies of UFOs, you always end up with a number somewhere around that. Somewhere around 90% of all of these things are, they're lights in the, they're jet planes that are moving towards you and then suddenly veer away, and suddenly it looks like, oh my God, it made this incredible right-hand turn. It's celestial phenomena, it's satellites. So, I mean, that's what people should understand, that, like, without a doubt, you look at the history, 90% on order of the stuff can be explained. The stuff that can't be explained, some of those are certainly freaky deaky, right? So like in the book, I go through, so James McDonald is an interesting character. So in the UFO reports start in 1947 with, I think it's Kenneth Arnold was his name. He was a pilot who saw these, he saw some things as he was flying, I think 9 lights that were moving in irregular ways. We can go back to that, but that was the beginning of the whole UFO craze. And then within a year, there were 800 sightings of UFOs, flying saucers in particular. Let's put a pin in that and go back to it. But so since then, the military has done a couple of reports, couple of studies. There's the Condon report in the 1960s, which also did a scientific study. They all, again, end up with this number somewhere around 90% can be explained. But James McDonald was an atmospheric physicist who looked at the Condon report and really felt they had not done a very good scientific job. And he went back, he looked at the unexplained categories and went back and did interviews with the people who were around him. And some of, and he was a very respected atmospheric scientist. And some of the stories, or some of he relates, I think, 5 or 6 cases in his paper. He wrote a very well-known paper called The Estimate of the Situation. And some of them are definitely freaky deaky, right? I mean, they're like ghost stories. They raise the hair on the back of your neck. But again, all they are stories, and sometimes there were radar reports, but nobody has the radar data. So, what you're left with are just stories, right? There's no hard data that, like of the kind that you use to build your cell phone, or of the kind that we use to build these incredible technologies that allow you and I to talk. And without that kind of data, we're all just left with stories, right? And science doesn't work on stories. Science works on research. So at this point, as I say, there's really no reason to think that any of the UFOs have anything to do with aliens. It's clear with the stuff associated with the UAPs that some of these military, the military training exercises are having a lot of seeing things. The pilots, I think, are being honest in what they remember seeing. Remember, memory is never a record, but I think they're being very honest and they're being courageous and coming out and saying, look, we're seeing something. I would bet that those things are going to end up being about peer state adversaries. This is going to have military consequences. But let's do the study, right? The only way, as I talk about, so in the book, I have a whole chapter where it's like, okay, look, if you really want to do a scientific study, if you want to go beyond just blobby photographs, and you really want to know, then here's how you do it. Here's what a scientific study of UAPs would look like. So I run through that, and it would be about, you got to build your own sensors. You got to build your own instruments. You've got to deploy them rationally. And then you need some rational strategy for sorting through the data to be able to say what's a false positive and what's a positive in terms of seeing things. So until we do that, we're just going to be left with, the conspiracy theories. And there are so many. It's just, that's the problem with UFO, the culture of UFOs. It's been nothing but conspiracy theories and, really, I don't know how to say this, conspiracy mongering and ideas that just, they're all over the place. Any evidence is evidence, right? It doesn't matter, there's no quality control on what's considered to be evidence for anything. So the only way to really do this is to do it the same way we scientists have to do it, which is where you build your own instrument, you beat the instrument to death in terms of understanding it, and then you go out and take data in a way that is clear and transparent, and from which you can derive conclusions. I guess just to put a fine point on this, and we can expand on it, but is that what people have to understand is the reason why their medicines work, and the reasons why their jet planes don't fall out of the sky, and the reasons why these cell phones, these miracle boxes work, is because science is absolutely brutal about the relationship between evidence and a conclusion drawn from that evidence. Like, we beat the crap out of each other in science in making sure that link is firm 6 ways to Friday. And there's no reason why UFOs and UAPs should not be subject to the exact same standards. And based on those standards right now, there's nothing that comes even close to linking anything we've seen in the sky with an idea that these are alien visitors.
And also, speaking of the miracle boxes that we have in our pockets, you would have thought that, given the amount of eyewitness testimonies over the past few decades, you would have thought that, well, surely over the past 20 years we would then have incredible video footage, because these eyewitnesses now have an amazing camera in their pocket. But that doesn't happen.
Can we expand on that just for a second?
Yeah, of course.
Because this is, in the chapter, there's one of the chapters I have sort of two of my main objections to UFOs. The first is exactly what you said, right? I mean, the first UFOs were 1947. We're now very far downstream from that. Camera technologies become so advanced, and yet still what we have are blurry photos, right? I mean, after all this time, the resolution of cameras and the availability of high resolution cameras, everybody's got one in their pocket, and you still have UFOs being nothing but blurry photos or hoaxes when they're sharp. And remember the Chinese spy satellite or spy balloon? There's an amazing photo that the pilot of the U-2 spy plane took when he was circling the balloon, and he held up. It looks like he's holding up a cell phone, and he snaps a picture of himself. You can see his helmet in this thing, and there you can see the spy balloon, and you can see the seams on the balloon. You can see the solar panels in the payload hanging below it. You can make out the most extraordinary details on this what was previously an unidentified flying object. And so, like, come on, if the sky was full of these alien spacecraft, we'd have thousands of high resolution images like that. And my other objection I just want to bring up is what I call the high beam argument. Like the idea that like there's all these aliens, they're visiting us, they have super high technologies, they don't want to be found, right? They're not just landing on the White House being like, hey, we're here. And so they want to remain cloaked, but they suck at it, right? Because they keep, like they leave their lights on. They're constantly being seen and then disappearing. And it's like, look, man, if you really want to be cloaked, then turn your lights off. It's not that hard. Right. So that's what in one of the chapters in the book, I sort of run through those arguments. And that's what stretches the plausibility. I mean, at some point, it's these arguments that the previously, that most of the UFOs are alien craft just really stretches the realms of plausibility. But again, the only way to do this is to get data. As I said, there's some small number of these things that are freaky enough that, yeah, let's get the data and let's see where we go.
If we did happen to come across an intelligent life, an alien species, one of the things I've wondered is, would it even resemble us? Do you think evolution would come up with the same solutions to life emerging on another planet around a distant star?
Yeah, so this is a really interesting question, and then I have the last section of the book. The last whole section is what will we find when we find it, and there's ways in which we can use science, we can use understanding of physics and chemistry and evolution to try and at least put some constraints on that. And so the answer to that question really relies on us to look at evolution in particular and the logic of evolution. And what you find there is that, evolution, it works on, it's both constraints, physical and chemical constraints, and then accidents. Those are the two most important things in evolution. So constraints are like, look, if you evolve life on a world that's got an atmosphere, relatively dense atmosphere, then certainly one way to get around would be to have your life have these sort of curved surfaces, extensions with curved surfaces, obviously wings, and use that to be able to take flight, because the physics and chemistry, or physics in particular, allows, if you have a curved surface and you have a flow over it, you'll get lift. So in Earth's history, you see wings evolving a number of times in completely different lineages, right? So insects have wings, mammals have wings, birds have wings. They're all very, their last common ancestor is so far in the past that the fact that wings evolved in all those cases tells you that there was a certain amount of convergence of form. On the other hand, the evolution works by random mutation, and the ability of a random mutation to fit into changes in its environment better than something doesn't have that mutation. So that's a lot of accidents right there. And as the great biologist, I'm sorry, wait, I forgot. I'm gonna blank on his name all of a sudden. The author of Wonderful Life, as he said that if you were to roll the tape of Earth's life back and start again, 3 billion years ago, none of the species you see today would exist. You'd have life, you'd have things in the ocean, you'd have things in the air probably, but they wouldn't look anything like what we have today. And in fact, there's been experiments that have looked at the balance between convergence and accidents, contingency. And what they find is contingency tends to win. So this also speaks to the UFOs, right? Because, all the idea of the grays, as they call them, these little triangle-headed aliens that look pretty much like us. They're a head on shoulders with 2 arms and 2 legs. No way. I mean, it's going to be very hard to argue that you're going to get that level of specificity of convergence, that you're going to end up with things that literally look just like you, except, well, their heads are a little bit different, or they've got little antenna on their foreheads, or they've got pointed ears. I mean, come on, that's just not really the way evolution works. So we should expect to be surprised. We should expect also maybe to be grossed out quite a bit, because, the forms, nature is more inventive than we are. I mean, look at a kangaroo, right? I mean, what is a kangaroo, right? It's like a giant rabbit that can punch you in the face, right? There's so many examples of Earth's history that are so bizarre that if you just started with a cell, if I gave you a single cell 3 billion years ago, would you be like, oh, yeah, there's definitely going to be a kangaroo coming out of that one? So, yeah, there's just no way to predict really. And this is actually formally, I study I'm got projects now in the physics of life and thinking about the progress, the ways life can evolve. And there's just no way to say which direction life is going to take. So we should expect to be radically, radically surprised.
Let's finish on imagining that we have definitively found intelligent alien life, and that we've even made contact. What's the effect on humanity, generally speaking, scientifically speaking, astronomically speaking? I mean, what are your thoughts on that?
Well, sometimes people think like, oh, everybody's going to freak out and there's going to be like riots in the street. That's not going to happen, right? Unless they land and they want to eat us. Yes, then there's definitely going to be riots in the street. But, look at like the technologies we have, right? We get these new technologies where suddenly, like when I grew up when like the idea of having a video conversation was some kind of like super high tech and it was going to change everything. And then we got it and 15 minutes later, we're like, man, the quality of my video is really bad, right? So human beings are very adaptable. However, having said that, it will still be, into the long term, it'll be the most profound scientific discovery in human history. And it will, like there was not going to be riots in the street, but, give it 10, 20, 30, 40, 100, 200, 400 years, it's going to reshape how humanity thinks about itself, its own destiny, and our place in the universe. Because here's the thing, right? Right now, we do not know whether life was an accident, like life itself was an accident, that there's no place else in the entire universe where life has occurred. And why is that important? Because as we talked about a moment ago, life is unlike any other physical system, right? If you give me a star and tell me that star's mass and its chemical composition, I can pretty much tell you its whole history. I mean, the details may, things are going to be different, but overall, I can tell you its whole history. As I said, if you give me a cell and ask me to, and when I come back in 3 billion years, what's going to happen? No way. Life is inventive. Life is creative. Life is innovative. So if we find just one other example of life, I don't care whether it's intelligent or microbes, what that means, if you find one other example, then it's pretty easy to imagine that there's lots of examples, right? We weren't an accident. And then in that case, all bets are off, right? Because life is inventive, who knows what it's done? Who knows what it's evolved into, whether here in this galaxy or the galaxy next door or some galaxy a trillion light years away. It just means that this innovative capacity that the universe has the possibility of multiplying to the nth degree. And then really, right, things like I'm not a big fan of the simulation hypothesis, but just because life is so creative and so potent, it's very hard to predict what it might do or where it might go and what the consequences of that are. And so it just really profoundly reshapes our understanding of what we are in the universe. And if we ever found, we're at a moment right now because of climate change and all the other issues we face, it's not clear that humanity is going to be here in another 1,000 years. So finding one example of a civilization, and we wrote a paper a few years back that showed if you find another example, it's probably going to be older. Finding one other example of a civilization that's older than us would tell us that it's possible, right? We don't even know if a long-term civilization is something that the universe does. Maybe that's just not in the list of things the universe builds. So just finding one other example would show us, like, there's some hope for us that maybe we can manage our stupidity, and our angelic qualities together to be able to go forward. So I think it would be the most important discovery humanity had ever made.
I think that's a really nice note to end the podcast on, Adam. Thanks very much for coming on and for sharing your wisdom. And it's been incredible. It's been quite a journey, the podcast.
Yeah.
This episode. And good luck with the book when it comes out, Little Book of Aliens. Hopefully get to speak to you again sometime in the near future as well.
I would love that. This was a really fun conversation. Thank you.